Hello, welcome back to JK Chemistry. Today we are going to deal with the rules of resonance. Okay, so there are certain rules that governing how to draw resonance structures. Okay, so among different kind of resonance structures, which one is most stable? These things we can just learn here. The first rule is that we want to draw the resonance structures in the plane of paper. So the resonance concept is that, so if you are drawing a Lewis structure for a given molecule, so suppose you are unable to draw within a single structure, so such a phenomena is called a resonance. So in resonance we can have different Lewis structures. Okay, and this contributing structures is called resonance canonical forms. Okay, next thing is that is the most important thing in resonance structures or resonance phenomena. You are allowed to move electron only. So your arrow, we know that arrow, a double barbed arrow means a pair of electron is moving. So that is very important. You should move electron only. Suppose if you are moving an atom, it is not at all resonance effect. It is another kind of phenomena is called tautomerism. It is called tautomerism. So in the first picture we can see the pi bond is moved to the next CC sigma bond. Okay, though you can have a positive charge in the another carbon atom. So here we can see a pair of electron is moved from one pi bond to another sigma bond. So it is merely a pair of electron movement. So it is a resonance form. But in the next structure, what you can see? What you can see? That is a hydrogen is moved from first carbon to the second carbon. Thereby the positive charge is shifted to the first carbon. Whether it is resonance? No, it is not at all resonance. It is called tautomerism. Why? Because the relative position is changed. So it is very important in resonance structure, relative positions of atoms are the same and the electronic movement should take place, not a species or atom. Okay. And next rule is that every atom, every second row element should obey octet. That means you are not allowed to exceed octet of second row element. So in the given example, carbon exceeded its octet, right? So it is not a good resonance form. Okay. Next rule is that the energy of a resonance hybrid is lower than that of energy of contributing structure. That means if you are drawing many resonance structures, you can have many canonical form. And finally you can have highly stabilized structure is called resonance hybrid. Okay, resonance hybrid. So the well-known example for benzene is, you can see two extreme canonical form, and in resonance hybrid you are representing these 6 delocalized electron as a circle. That is called resonance hybrid. In a resonance hybrid, that means here you are representing the cyclic movement of electron. So in resonance hybrid you just represent that movement as a circle, that only. So the thing is that resonance hybrid is the most stable structure of the given molecule. Okay. And if you have many contributing structures, so among these different contributing structures, one of the structure will be the stable one. Okay, so that stable structure is very close to your resonance hybrid. Okay, അതായത് ഒരുപാട് കോൺട്രിബ്യൂട്ടിംഗ് സ്ട്രക്ചേഴ്സ് നിങ്ങൾക്ക് ഉണ്ടാവും. അതിൽ ഒരു സ്ട്രക്ചറിന് തന്നിട്ടുള്ള സ്ട്രക്ചറിനെ അപേക്ഷിച്ച് എന്തായിരിക്കും സ്റ്റെബിലിറ്റി കൂടുതലായിരിക്കും, അയാൾ നിങ്ങളുടെ റെസണൻസ് ഹൈബ്രിഡിൻ്റെ എനർജിയായിട്ട് വളരെ ക്ലോസ്ഡ് ആയിരിക്കും. ഓക്കെ, നൗ നെക്സ്റ്റ് വി ആർ ലുക്കിംഗ് ഇൻ ടു ഹൗ ക്യാൻ ബി പ്രെഡിക്റ്റ് എ സ്റ്റേബിൾ canonical form. Okay, so here in this lecture we are dealing with how can we predict a stable canonical form among the different canonical form. That means നമുക്ക് തന്നിട്ടുള്ള canonical ഫോമിൽ ആരാണ് കൂടുതലായിട്ട് റെസണൻസ് ഹൈബ്രിഡുമായിട്ട് മാച്ച് ചെയ്യുന്നത്, റെസണൻസ് ഹൈബ്രിഡിൻ്റെ എനർജിയായിട്ട് കൂടുതൽ മാച്ച് ചെയ്യുന്നത് എന്ന് നോക്കാൻ കുറച്ച് എംപിരിക്കൽ റൂൾസ് ആണ്. ഓക്കെ, the first thing is that the more covalent bond structure has more stability. Okay, that is number of covalent bond increases, stability also increases. That means it is very close to your hybrid structure. For example, in the given structure, okay, so you have a formaldehyde 2 form. Okay, one having one have 4 covalent bond, second having only 3 covalent bond. That means the first structure is more stable than that of the second structure. Okay, second rule, charge separation decreases the stability. That means charge separation is unfavorable. Okay, so let's check the example. Okay, the same example, first structure having any kind of charge separation, second structure having a charge separation. So the structure one having charge separation is less stable than that of structure without charge separation. So the stable structure is first one, and which that one is very close to your resonance hybrid. Okay, next rule is that atom having noble gas, that is its octet. So structure obeying octet, that is more stable compared to structure without octet. For example, the same structure. So first one having carbon having 8 electrons surrounding it, oxygen having 8 electrons, but the second structure carbon having only 6 electrons surrounded. So we can say that in the first structure carbon having octet, so that structure is more stable compared to second structure. So the structure A is more closer to your resonance hybrid. Finally, negative charge. If you have a charge separation, then the negative charge is more preferable on more electronegative atom, not electropositive atom. For example, you can have ketoenol form. Okay, so the first structure you can have a negative charge on oxygen, second structure you can have negative charge on carbon. So we know that oxygen is more stable, so first structure is more stable, and that one is more closer to your resonance hybrid. These are the some empirical rule how to predict more stable canonical form. Okay, so these are the some practicing problems. So according to this arrow you have to predict the next canonical form, and among these two which one is more stable. So you have to predict stable one. Okay, clear? Thank you, take care.